Okay, so today I'm going to go over Earth spheres, and we'll try to talk about each one a little bit. So first of all, Earth's geosphere, lithosphere, biosphere, atmosphere, and hydrosphere are going to be defined according to their function in Earth's system. And the reason that we divide the Earth into spheres is because it's easier to to understand like the environmental issues, and also to make Earth's complexity a little bit easier to understand. So you need to know, all the spheres, and you need to know how to define each one. So I'm going to scroll down a little bit so you can see the diagram. Okay. And I'm going to start with the geosphere, and you can see the geosphere is here. Okay, Earth's geosphere is made of all the rock at the Earth's surface and also all the rock below the Earth's surface. Okay, the lithosphere, which is up here, right, is the hard rock on the Earth's surface and the hard rock just below the Earth's surface as well. It's the outermost layer of the geosphere. So you see how they kind of they're connected, and one is part of the other. The biosphere, remember bio means life, the biosphere is all of the planet's living things and the non-living parts of the environment that they interact with. Okay, so here is the biosphere. So it's going to go a little bit below the Earth's surface because there's organisms, especially like bacteria, that live in the earth, in the soil, and then it's going to go up above the surface because you know that there's organisms that live in the air as well. Okay? The atmosphere consists of the layers of gases surrounding our planet, and the hydrosphere encompasses all of the water, salt water, fresh water, obviously liquid water, but also ice water and vapor on Earth's surface, underground, and in the atmosphere. And you'll learn more about Earth spheres here in a little bit, but I just wanted to point them out first. So I'm gonna so those are the spheres there. Again, this is the surface of the Earth here, and then the further you go in, now we're going into Earth's layers, right, all the way up into the very center of the Earth, or the core. All right. So let me go up here so we can focus on each sphere a little bit more. Okay. So the movement of Earth's plates has formed the deepest ocean trenches and the highest mountains. And I know you talk a little bit about this in biology, okay? But let me go over here. We're just going to talk a little bit about the geosphere, particularly the Earth's crust and mantle, and how the movement of it is what creates those crusts. I mean, those mountains and those trenches. Okay. All right. So the geosphere. Earth's geosphere consists of the crust, the mantle, and the core. That's the geosphere: crust, mantle, core. Rocks and minerals on and below the Earth's surface. Crust is thin, cool, rocky outer skin of the Earth. The mantle is very hot, but mostly solid. And the core, the outer core, is molten metal. The inner core is solid metal. All right, so that's your geosphere. Okay, now plate tectonics. All right, so there's the asthenosphere. The asthenosphere is the soft middle mantle heated by outer core. And since it's soft, as the asthenosphere moves, it drags along large plates of lithosphere called tectonic plates, which is defined right here, right? So the asthenosphere moves, it drags the tectonic plates. Earth's surface consists of about 15 major tectonic plates, most of which include some combination of ocean floor and continent. So if you could, imagine peeling an orange and putting pieces of peel back onto the fruit. The ragged pieces of peel are like the plates of Earth's crust, and these plates move about 2 to 15 centimeters per year. All right, so this movement over time not only has affected our climate and life's evolution as the continents have combined, separated, and recombined, it's also created a lot of change. Again, the appearance or disappearance of mountains and trenches as well. Okay, so here is where this is kind of the highlight here. Convection currents in the asthenosphere move tectonic plates. Collisions and separations of the plates result in landforms. That's how we get our trenches and our mountains. Okay, so here's a little bit more about tectonic plates because depending on how they move and what they do, defines them. So there are three major types of plate boundaries. There's divergent, transform, and convergent. And I'm going to go over those three here a little bit. Okay, let me see. Hold on 1 second. Let me see on here. Yeah. Okay, there we go. So at divergent plate boundaries, magma, also known as molten rock, surges upward to the surface and pushes plates apart. This is why they're called divergent, and it creates new crust as it cools. And you could see in the diagram here, right, they're separating. A prime example is the Mid-Atlantic Ridge. It's part of a 74,000 kilometer system that cuts across the ocean floor. Plates expanding outward from divergent plate boundaries at mid-ocean ridges, they bump against other plates, forming transform or convergent plate boundaries. So again, that's why it's called divergent, because they it pushes plates apart. They diverge from each other. Okay. Transform boundaries, when two plates meet, like they kind of rub against each other. They may slip and grind alongside one another, and when this happens, they're forming a transform plate boundary. The friction between plates at transform plate boundaries will often cause earthquakes, and this often. The Pacific Plate and North American Plate, for example, rub against each other along California's San Andreas Fault. And that's the origin of many of North America's most severe earthquakes, because again, that is a major fault. They're called in California. So those are transform plate boundaries. All right. Convergent plate boundaries. Let me scooch down here to the picture. Convergent plate boundaries is when plates collide at convergent plate boundaries. I'm sorry, when plates collide at convergent plate boundaries, one of two things will happen. One plate of crust may slide beneath another in a process called subduction, and the subducted crust is heated as it dives into the mantle because obviously it gets melted, and it may send up magma that erupts through the surface in volcanoes. So Mount St. Helens in Washington, which erupted in like really bad in 1980, became active again in 2004, is fueled by this kind of action where it's fueled by magma from this process called subduction, right? And you could see it right here. This is a great little diagram right there of subduction. That's one thing that can happen. The other thing that could happen if subduction doesn't occur is the two plates may collide, slowly lifting material from both plates, like right here, in a process called mountain building. So like the Himalayas, which are the world's highest mountains, formed through mountain building. They are the result of the Indian-Australian plates collision with the Eurasian plate 40 to 50 million years ago. So the Himalayas to this day are still uplifting higher and higher slowly, but it's the mountain is still building. So those are the different convergent plate boundaries. Okay, make sure, I think the diagrams really help to understand this. Just make sure that you know the different vocabulary terms that describe the pictures here. Okay, all right. Then we go on to the biosphere and the atmosphere. Okay, so again, the biosphere is the part of the earth in which living and non-living things interact. Um, the atmosphere contains the gases that organisms need, such as oxygen. It keeps Earth warm enough to support life. And I want to point out, the spheres are not black and white. For example, some of the atmosphere is a part of Earth's biosphere. So again, just keep that in mind. Let me go down here to the hydrosphere. Hydra as in hydrate, water. Um, let's see here. The hydrosphere. So you know from even elementary school, we go over the water cycle, but water cycles through the lithosphere, biosphere, and atmosphere continuously, right? Water is constantly cycling. Sometimes it takes a long time, sometimes it doesn't, but it's constantly cycling. All right, so the hydrosphere consists of Earth's water. Most of Earth's water is salt water. We have very little fresh water. Only 0.5% of Earth's water is unfrozen fresh water, usable for drinking or irrigation. The rest of the fresh water is frozen. It's actually quite hard to get to. So Earth's available fresh water includes surface water and groundwater. It's surprising how little liquid fresh water we have for drinking, actually. Okay, but that's the hydrosphere. Um, the reason it's so important, obvious, and I know this is obvious to you, but still, let's point out the obvious. Water is essential to life, but we frequently take it for granted as a means of transport and as a solvent. Water plays key roles in nearly every environmental system, including all the other cycles of matter and the life processes of every organism in the biosphere. All right, so I know that's obvious, but I really had to point that out. Let me go down here. All right, I'm trying to go slow so you guys can see the diagrams really well here. All right, here's a diagram of the water cycle. Okay, the water cycle, or you can call it the hydrologic cycle, is just a summary of the roles that water plays in our environment. Sometimes it's in liquid form, gaseous form, or solid form. Evaporation, transpiration, precipitation, and condensation are the major processes of the water cycle. And we've I know you've gone over the water cycle before and all of these vocab terms, so I'm just going to quickly go over what each of those terms mean, but I have to go down here away from the picture, which is great, to, let me see, actually, hold on, no, let me quickly go over those vocabulary terms. So water moves from bodies of water and moist soil into the atmosphere by evaporation. That's when water goes from like maybe a liquid to a gas because it heats up, and that's the conversion of a substance from a liquid to a gas, like I said. Um, Usually warm temperatures and strong winds makes water evaporate even faster. Um, Water also enters the atmosphere by transpiration, and that's the release of water vapor by plants through their leaves. This is partially why it's so much more humid in a forest than it is out in an open field because there's a lot more leaves releasing humidity. Evaporation and transpiration both distill water naturally, and it creates pure water by filtering out minerals and pollutants. And so small amounts of water will end up entering the atmosphere as byproducts of cellular respiration and combustion. Okay, precipitation. That's the fancy word for rain. So water returns from the atmosphere to Earth's surface as either precipitation in the form of rain or snow. Um, it occurs when water vapor undergoes condensation, and condensation is a change in state from a gas to a liquid. So what will happen is water will evaporate into the atmosphere, but once it gets high up into the atmosphere, that water vapor cools down. And when a water vapor cools down, it turns back into a liquid. The liquid up in the atmosphere gets too heavy, so it falls back down to the earth as precipitation, also known as rain or sometimes snow too. Okay, and I think just a couple more terms here. We've got groundwater. Groundwater is really important. Some precipitation and surface water gets soaked down through the soil and rock to recharge those underground reservoirs or storage areas of water known as aquifers. Aquifers are layers of rock and soil that hold groundwater, fresh water found underground. Um, as a matter of fact, that's how a lot of us get our drinking water if you're on a well. The upper limit of groundwater held in an aquifer is called the water table. So groundwater can take hundreds or even thousands of years to recharge fully after being depleted, if it ever even recharges. So just because there's groundwater there now, if we use it all up, that doesn't necessarily mean that it'll refill again eventually. It might not. So those are the basic terms for water cycle. Now, human impacts. Human activity can affect every aspect of the water cycle. So by clearing plants from Earth's surfaces, we increase runoff and erosion, and increase evaporation and reduce transpiration. Um, by spreading water on farm fields, we can deplete surface water and groundwater and increase evaporation. And then by releasing certain pollutants into the atmosphere, we cause precipitation to become more acidic as well. Um, I think one of the most threatening things to future water supply is depleting groundwater with overuse for irrigation and industry sometimes. So the depletion sometimes can be bad enough in some areas like South Asia and the Middle East and American West that water shortages are like a really serious problem at times. So that's the water cycle in a nutshell. Um, I'm sorry that I can't be in class today, so I will see you tomorrow. Also, if I spoke too well, I'll see you tomorrow. Sorry.